If I wanted to know whether a new potting soil worked really well for my plants, it would not be a good idea for me to just go get the potting soil and put some plants in it and let them grow, because I wouldn't really know whether the potting soil was what made a difference, because I don't really have anything to compare to. And this is where the idea of a controlled experiment comes in. The idea is that we separate our sample into two groups. The first group is called the control group. The second group is called the treatment or the experimental group. So we divide the population into two groups. The treatment group, not surprisingly, gets the treatment, whatever we're testing. So in the case of potting soil, this would be the new soil. So I'd plant several plants using the new soil. The control group does not get the new soil. Now, I can't just leave plants, without any soil, so I would probably use the old soil here, and that would give me a nice comparison. Now, when we do testing, let's say, of a drug, we would give the treatment group some new drug, like some new headache medicine to test out. The control group, if we give them nothing, that actually turns out to not be a good idea, because people tend to have psychosocial reactions to things, mental responses to just taking a pill. And so typically we use something called a placebo, which is basically a fake treatment. So it might be something like a sugar pill in the case of medicine. In this case, it's kind of old soil, though this is more just a comparison group. So it's a fake treatment so that the groups are really equivalent in every way except for the treatment. So let's look at some examples. To determine if a 2-day prep program would help high school students improve their scores on an SAT test, a group of students were randomly divided into two subgroups. The first group, the treatment group, was given a 2-day prep course. The second group, the control group, was not given the prep course. Afterwards, both groups were given the SATs. So is this a controlled experiment? Absolutely yes. We were even told that this is the control group and this one was the treatment group. So yes, absolutely, this is a controlled experiment. Is it placebo-controlled? And the answer there is no, because the second group was not given the prep course, and so they didn't receive any kind of fake treatment in any way. If not, is that okay? Now, that's a really good question. In this particular case, if we're really just wondering, does this prep course do better than nothing, then yeah, it would be okay. So I'm going to say maybe. Now, what we could do, if we really wanted a comparison, would be to give the control group sort of a study on your own book to see if the prep course does better than studying on your own. But this one isn't, certainly a placebo is not necessary in this case. So suppose a company is testing a new plant food, and they grow 2 crops of plants in adjacent fields. The treatment group receives the new plant food, and the control group does not. The crop yield would then be compared. Is this a controlled experiment? Yeah, because they have the two groups, and they are controlling the for every other factor. So by putting them right next to each other, they should be very similar to each other. They should get the same weather, and in every other way be comparable. Is this placebo-controlled? No. If not, is that okay? Yeah. Yes, though they should probably get whatever they were kind of plant food they were getting before. So one more. Exploring the effects of alcohol on memory. One group is asked to drink 2 beers, perform a memory task. The second is given non-alcoholic beer in the memory task. So this is a controlled experiment. We have 2 groups, and this is placebo-controlled because one group is given beer, the second one is non-alcoholic beer, which is going to seem very similar, so the body is going to think that I'm drinking something, and so this is, the non-alcoholic beer here is acting as a placebo in this experiment.